day 70 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem. This time we're at day 70, guys. Hope you guys are still motivated, and I hope you guys are not losing any discipline because we're making some progress here. We're almost at day 100. We have about 30 days until day 100, and that's about a month away, guys. So I hope you guys are still interested, and I hope you guys are still excited about learning a LeetCode problem because we're making some progress here. Now, let's see what the question that we have here today says. Today we have question number 875, Koko eating bananas. The difficulty level is medium. So let's see what the question says, because you already know we're going to keep the solution as simple and easy to understand as possible. And this question is a little hard to understand, but don't worry, the solution is not as hard as the question to understand. But let's break it down. So it says, Koko loves to eat bananas. There are n piles of bananas. The ith pile has piles I bananas. The guards have gone and will come back in 8 hours. Koko can decide her bananas per hour eating speed of K. Each hour she chooses some pile of bananas and eats K bananas from that pile. If the pile has less than K bananas, she eats all of them instead and will not eat any more bananas during this hour. That's important to understand. I'll tell you why later. Koko likes to eat slowly but wants to finish eating all of the bananas before the guards return. Return the minimum integer K such that she can eat all of the bananas within 8 hours. So what we're trying to do is we're trying to see how many bananas. So the output is how many bananas she has to eat an hour before the guards come back in 8 hours. And this input piles, this list of integers, or this array of integers right here, is represents the amount of bananas in each pile. So this pile of banana has 3 bananas. This pile of bananas has 6 bananas. This pile has 7 bananas, and this pile has 11 bananas. And she has to eat 4 bananas an hour if she wants to eat all of these bananas before the guards return, right? So let's break that down so we can see how we're going to do that and how it all adds up. So first, we will try 1. First, we're going to start at 1 and see if she could eat one banana per hour and see if that will allow her to eat all of the bananas. So first, say she eats 1 banana per hour. This pile right here alone is going to take 3 hours. That leaves only 5 hours left before the guards come back. This pile alone will take 6 hours. We're already at 9 hours between these two piles, and the guards are already back. They've been back an hour because they only left for 8 hours. So we want to find how many bananas she has to eat per hour before, so she could eat all of these bananas before the guards come back in 8 hours, right? So that's the logic of what we're looking for, what the output is representing, right? So let's just plug the output in so you can see how it works, right? So the output says she has to eat 4 bananas per hour if she wants to eat all of these bananas before the guards come back in 8 hours. So how that would work would be, first, this pile right here, she could eat that in 1 hour because she's eating 4 an hour. But that's why this is important right here, because it says she will not eat any more bananas. Says she eats all of them. Start from the beginning. It says if the pile has less than K bananas, she eats all of them instead and will not eat any more bananas during this hour. So this hour right here, she's going to eat 4. Easy. That's 1 hour. We still have 7 hours left. This pile right here is going to take her 2 hours because it's going to take her 1 hour to eat 4. Then she's going to need another hour to eat the extra 2. And she's not going to move on to this pile within the same hour. That's what this is saying. It says she will not eat any more bananas during this hour. So it's going to take her 2 hours to finish this pile right here, because the first hour she'll eat 4, the second hour she has to finish the last 2. So let's start from the beginning so it makes sense. This pile she could eat in 1 hour. Boom, we have 7 hours left. This pile right here is going to take her 2 hours, right? So now she has 5 hours left before the guards come back. This pile as well is going to take her 2 hours, and that is going to leave her with 3 hours left before the guards come back. But luckily, if she's eating 4 per hour, she could finish 11 bananas in 3 hours. So that's going to maximize all of the hours, and that's the least amount of bananas she can eat per hour if she wants to finish all the bananas in under 8 hours. So let's look at example 2 because it's a little easier to understand given the numbers that we're working with. But the input piles list of integers, h equals 5 in this case, and the output is 30. So let's break it down. Let's go through it and see how it works. So she eats 30 bananas an hour. That means she could eat this whole pile in 1 hour. Boom. Then she could eat this. That leaves us with 4 hours left. She could eat this pile in 1 hour. Boom. That leaves us with 3 hours left. She could eat this pile in 1 hour. Boom. That leaves us with 2 hours left. She could eat this pile in 1 hour. Leaves us with 1 hour left. And she could eat this pile in 1 hour, which leaves us with 0 hours left. But the guards get back she finishes the bananas just in time before the guards get back because she's eating 30 bananas per hour. Now let's look at example 3. One last example before we get to the code. So this input, we have the input piles, the list of integers. This time, h equals 6, output equals 23, right? So output equals 23. That means it's going to take her 2 hours to eat this because she's going to eat 23 in the first hour. Then she's going to eat the remaining 7 in the second hour. So this is going to take 2 hours. That leaves us with 4 hours left. She could eat this in 1 hour because she's eating at least 23 an hour. So she could eat 11 fast. That's easy. Boom, that's 1 hour. So that leaves us with 3 hours left over here. She could eat 23 in 1 hour. We have 23 bananas. She could eat that in 1 hour. That leaves us with 2 left over here. Boom. She could eat that in 1 hour. Easy. Only 4 bananas. That leaves us with 1 hour left before the guards get back. And there's only 20 bananas left in the last pile. And so she's eating 23 an hour. So she could eat that in 1 hour as well. And she could finish the last pile just in time before the guards get back. And there's 0 hours left. So now that we understand what the question was asking, I know there's a lot to take in. And I know it was a little difficult to understand at first, but once you kind of get the logic of what they're asking, it's easier to understand. So now that we understand the question, let's see what the code says. And the code is not that difficult to understand at all. So the first thing we're going to do is we're going to declare a variable called L. We're going to set that equal to 1. Then we're going to come down here, declare another variable called R, and we're going to set that equal to piles.max. And then it's an optional, so we're going to put the exclamation point at the end. Then we're going to come down here, declare another variable called res, and we're going to set that equal to R. Then we're going to say, while L is less than or equal to R, we're going to come down here. You already know the first thing we need to do is find mid. So first thing we're going to do is say let mid equal, open up the parentheses, L plus R divided by 2. Then we're going to come down here and we're going to say, declare another variable called hours. We're going to set that equal to 0. Then we're going to come down here and we're going to say for P and piles, we're going to say hours, plus equals, open up the parentheses, P plus mid minus 1. Then we're going to say, then we're going to come over here and we're going to say divided by mid. Then we're going to come outside of that for loop and we're going to say if hours is less than or equal to H, then we're going to come down here and we are going to say res equals min mid comma res. Then we're going to come underneath that and we are going to say R equals mid minus 1. Then after that we're going to come down here, we're going to say else. Then we're going to say L equals mid plus 1. Then after all that, we're just going to come down here and we are going to return res, guys. So let's run it, see if it works. Should work, but let's see if it works just in case. And it's accepted, guys. So get one more look at the code. one more time before we submit it. Get some of that good code. Look at that good code. Now let's submit it and see what that time is looking like, guys. Fingers crossed. And it is 99 milliseconds, beat 66.82% of users with Swift, guys. That's not bad. It's not bad at all. We're still learning, so don't be too hard on yourselves, or if it's hard to understand, or it's going to take you a little longer to understand, don't worry about the time. Just worry about what you're learning and the knowledge you learned today. And I hope to see you guys tomorrow for another day, another LeetCode problem. Peace.